everyone, FusedVR coming at you, and hope this video finds you doing super well. Got a really exciting video for you guys today. What we're going to be working on is getting a fresh Unity project and getting that to work with Oculus Quest as well as the universal render pipeline. Now, this is basically going to be part one of a list of several videos that we'll be going over, and I kind of detailed that in the previous video, so if you haven't checked that out, I'll make sure to leave a link to that in the iCard so you can definitely see what we'll be building up to. But I figured this video would work as a very easy and straightforward part one as we start working towards some of the more complicated topics such as the directional shader and the visual effects shader that seems to be of interest from talking to you guys in the comments. So let's start here, and kind of the earlier parts of this video are going to be some pretty easy setup, but I think the more interesting component is actually going to be towards the middle part of the video when we actually kind of dissect one of the custom shaders that Oculus used for hand tracking, and that was built with the built-in render pipeline. So what we'll be doing, and honestly this is going to be most of this video, is converting that shader approximately to shader graph so that once it's in shader graph it works with the universal render pipeline and we're good to go there. So that should be a super exciting topic, and I think it'll be super useful just to get our feet wet a little bit with kind of shaders in general, so it seemed like a pretty good place to start. And it's going to be an approximate effect, but I'm not doing this perfect just because there are actually limitations with shader graph, so we can't get the effect as perfect as say Oculus has done, but we can get pretty close, and I think for the majority of use cases I think that'll be good enough. So I did want to preface that pretty early on, and the other thing I wanted to do before we get started is mention that something that kind of came up as part of recording this video is there are probably a couple of mini topics here. So one thing might be like coordinate systems, for example. If I don't dive into that at all in this video, but if that's something you guys are interested in, let me know in the comments below. I might spend some time, just make like a 5-10 minute video, something pretty short just to explain what that is, just to kind of get some base understanding. If that's something that you guys are not interested in, also let me know as well, just to get a sense of framework, just because I think people come into VR with a lot of different backgrounds, and sometimes you kind of like the heavy mathematics of it, sometimes you like the kind of more design interaction type of stuff, so curious to hear what you guys think about that. So with that said, make sure to smash the like button if you find this video super helpful. It really does help out the channel a ton, and we can go ahead, open up a brand new Unity project and get started. Okay, gone ahead, opened up a fresh Unity project here. This is 2019.3, and there's a couple things we'll obviously need to set up to get all the pieces we need. So first, we're gonna have to switch over to Android, and this is just to save us a little bit of time later, just because sometimes the more stuff you have in your project, the longer the build settings takes. Okay, next, let's go ahead and get the universal render pipeline. So you can get that under the package manager here. Take a couple seconds here to load up everything, and then scroll down until you find Universal RP. Go ahead, click install for that. That'll take probably a minute or two. All right, once that's gone ahead and installed, you'll also see that shader graph has been installed, which is perfect since we'll be using that later. And last thing we'll need to do is go ahead, go to the asset store and grab the Oculus SDK. Go ahead and install or import it depending on your need, and that'll again take another few minutes. Okay, once that's finished installing here, there'll be a couple updates. We'll just click through yes on everything, and then it'll restart Unity, and then hopefully from there you have everything you need and we should be good to go. Awesome. Okay, so we can finally go ahead and get started here. First thing we're going to go ahead and do is find the train scene, since that's what we're going to be using just to test and make sure everything is working with the universal render pipeline. So that's going to be under the sample framework, under usage, and then this hand interaction scene. So this is what it looks like currently, and then we're going to break it all and then put it all back together. So let's just go to the top of the assets folder here, and then we'll go ahead and under rendering, go out to universal render pipeline, and then we'll create a pipeline asset here. I'm just going to call this URP just for simplicity's sake. And so this is all of the settings that we'll be using for Universal Render Pipeline. So you have all the textures that you might be using. Most of them we're not going to be using for our purposes, at least initially. You can set anti-aliasing, HDR, lighting quality, kind of all of the things that was originally under the project settings for graphics. It's now kind of been brought out into this folder here. And so we can pretty much for now just use all the defaults. That's pretty simple to do. And let's go to our project settings here. And the only other thing we need to do is go ahead and drag our asset that we just created and drop that under URP. You'll notice the second I did that, the scene went all nice gooey pink. And that's because we now have switched from the built-in render pipeline to the universal one, just like that. As a result, all of the shaders and materials that were using the built-in render pipeline don't work anymore. And as a result, we also need to go ahead and upgrade them. And so yeah, so that's that here. Real quick while I'm here, let's go to our player settings and let's just go ahead and enable VR support here by adding Oculus. And the other thing is probably in the future, those settings will jump to the XR plugin management. I particularly haven't played with this too much, and just for simplicity's sake, I'm just going to be using the player settings, but just I wanted to make a note of that in the future in case these settings disappear in future Unity versions. That's where to look for that. So let's go ahead, add Oculus. And the other key thing once you've gone ahead and added Oculus here is to switch from multi-pass to single pass. And the reason for this is because I'm not necessarily sure if this is a bug or not, but unfortunately, for whatever reason, multipass is not working with Universal Render Pipeline, so you will have to be switching to single pass. Otherwise, as a result, you get a black eye in your right eye. So that's a kind of important thing to keep in mind there. The other thing we'll go ahead and do is switch to Auto Graphics API, and the reason for this is because on Quest, where they don't support Vulkan, it's just going to be using OpenGL. So if you switch over to the Auto Graphics API, that'll automatically default into OpenGL as opposed to having to delete Vulkan there. So that'll take another few minutes just to get that set up. All right, so that should pretty much wrap it up for project settings here. We can go ahead and close that. So first order of business here is let's go ahead and correct all the materials. So if you're not working with this scene, that's totally fine. There's actually an easier way to do it. It's not going to apply to this scene, but I figured I'd show it anyway. So if you go to Edit, Render Pipeline, URP, and then you can go ahead and upgrade all your project materials. Doing that should be, well, it'll depend on the size of your project, but it'll work primarily if you're just using built-in materials and switching those guys over to Universal Render Pipeline materials. However, in this specific project, you can actually go ahead and look real quick. If we click on anything here and then we click on the material for that, you'll see on all of these, they're using a specific type of shader that is built by them, and there's no real clear and easy, straightforward way to convert custom shaders in order to work with the Universal Render Pipeline. So luckily for us, we don't need it to be completely perfect, and quite frankly, we can get away with just using some of the built-in Universal Render Pipeline materials here to work with just kind of the background that they've set up. And I'll show you here on just, let's say, for example, this background material. So you'll see that there's a base texture, a normal map, and this reflection map. We're actually going to be ignoring the reflection map just because there's not a good mapping there. But quite frankly, we can just go here, and instead of the Oculus sample shader, we'll go to URP, and we'll do a baked lit shader. And just like that, you'll see that we don't have the colors, but we are able to get some of the normals to work correctly, and that's purely because the normal map has been provided to us. And for some reason, it doesn't update the base map, but that's actually really simple and easy to do. We'll actually just click here, and it just so happens all of the correct textures are right next to it. So we just drag that onto the base map here, and boom, that looks pretty good. And so this is using the Universal Render Pipeline, so of course that's why this has started to work. And Now, if we go back here to our hand train example, and if we go to materials, we basically need to do that for pretty much all of these pink materials. I'm just going to do it for the core set. Obviously, if you want, you can go ahead and do it for all of them or however many you want, just to get it so that it looks somewhat correct. So let me speed through that real quick. Just done it for the core materials here. You can see pretty much everything looks good. I don't see any particular pink anywhere. So that means that this has worked, and I mean, it's really kind of only a core few assets here. So 1, 2, 3, 4, 5. This is all thanks to the fact that they've UV mapped these correctly and are sharing textures through an atlas, which saves a lot of time and performance. So that pretty much covers just one example of how you might go about converting them. And here we're using baked lighting because obviously this is a lot of these are static objects that have baked lighting with it, so it makes sense to use that. You can use any of the other ones really depending on kind of use case. If it's lit, simple lit, if you're using particles, etc. That's kind of where you would go about looking for all of that type of stuff, and that's probably the fastest way to go about that. Alright, so now that we have gone ahead, set up our materials, we have a scene that is now kind of at least basically ported. There's one last thing we have to do, and honestly this is going to be the kind of meat of this tutorial, if you will, and that's to get hand tracking to work with Universal Render Pipeline. So first we have to go ahead and take a look at the hands in and of themselves. So you can find that here just really quickly and easily. Just click on the hands prefab, and this is the hand. You'll see here again another custom shader, and what we're going to be doing is taking this shader and porting that over to Shader Graph. So it's going to be a nice easy way for us to spend a little bit of time learning about shaders. And I'm not going to go into crazy depth by any imagination, but I'm going to show you kind of very simply how to do this, as well as how you might do this for other shaders that you might be trying to port over. So for starters here, let's go ahead, take a look at the material. That's going to be the default hand material here. And one thing that's super important to note is whenever you're porting over any material, especially something like these hands, which are kind of animated, and these properties here basically can be changed at runtime. And so an easy example, for example, is the hands is this kind of fade out transition with the alpha. So those values can be changed and they can be updated at runtime. So it's the one thing you should keep in mind is for all these properties, when we're porting them over, make sure that the names stay consistent. And I'll point that over when we talk about the shader specifically. But so keep in mind those properties, and we also know that this is from the alpha hand outline. So let's go ahead and open up this shader. Okay, so here's our first look at the built-in render pipeline version of this alpha hand outline. Again, you can see the properties here, and as I mentioned, when we port over to Shader Graph, we're going to keep these names identical just so that the C# scripts that are using the names will be able to still reference them within our Shader Graph script. So I'll show you that in just a second. There's a bunch of stuff here, and quite frankly, if I scroll down to this surf part here is really the core part of what we're interested in. So there's a lot of extra stuff here, but I just wanted to highlight that this is the part that we'll be porting over. There's a lot of stuff that potentially could be ported over in the future. So like, for example, like lighting. However, Shader Graph is still a little early on and doesn't have a really good way of doing custom lighting. And there's this pass here, which is very important for really the one scenario where, let's say you have your hand wrapped up in a fist. In this built-in render version, you will not, even though the hand is actually alpha and see-through, this specific code right here will make it so that you won't see the fingers even when even though your hand is alpha. And it clips those vertices so that you don't have to see them. Unfortunately, Shader Graph doesn't support multi-pass rendering, so we only have the ability to pick one, and as a result, we don't have a really good way to emulate this code, and so we're going to be ignoring that for now. And it'll result in when you clench your hand up in a fist, you'll still be able to see those fingers, which will look a little weird. Well, we'll deal with that. It's honestly not the biggest thing in the world, but I think for simplicity's sake and also just for learning's sake, we're just going to be taking this surf shader here and then porting that over to shader graph. So that is what we'll be doing, and with that said, we can actually go ahead and get started. So you can put this pretty much anywhere. We'll just go to create and we'll go to shader and then create a Pbr graph. So this will allow us to do kind of physically based lighting and rendering. So it's pretty straightforward and simple there. I'll just call this alpha hand, and you can name it really whatever you want. Double click that to open it up, and let's go ahead and full screen that. So first thing we're going to want to do is set those properties that I mentioned at the beginning. So these ones right here. Let me show you how to do it for one, and then I'll speed through doing the rest of them because that takes a little bit of time. So we want this color primary here. So obviously we know it's a color, so we set that. We set the name here and make sure to have that underscore. And also for the reference, this is what allows the Oculus C# scripts to reference this as this underscore color primary within the C# scripts. So make sure the reference is set there. We'll also want to set a default. You can set it to this default values here. However, that's not exactly what the end result looks like. So if we go back over into Unity, let's bring up that default hand material. Okay, so on this one, you can see what the color primary actual value is. And I think that really easy way to do this is just go ahead, take the color picker off of the defaults, and then just kind of click on that. And that should be good enough. So that's probably the fastest way to do it. You could also just copy in the color values, but there, done. So now I'm going to go ahead and do that for all of these variables here and speed through that really quick. All right, so just gone ahead, added those properties here. Once you've done that, go ahead, click save. And again, I've just gone ahead for all these defaults. I have set that so that they just copied off of here on the material, just so that we actually get some pretty decent previews. So now that we have this set up, our job is now to go ahead and scroll down here to the bottom. We're going to be copying over this surf shader line by line as approximately as possible. So at a very high level, I don't want to go into too many specifics about how this actually works in high detail. I might say that for a separate video, although there's a lot of videos that go over kind of the render pipeline and shaders in general. So I'd encourage you to check that out if you're kind of curious as to how shaders work in general. I think that there's just so many great resources, but for our purposes here, we just want to make this effect work in universal render pipeline. So we're given a bunch of inputs here. So those inputs are these values. However, we don't actually need to use those. And then we have an output here. So the output is actually represented by this master node, if you will. And you can see here a bunch of properties that are being set and how they line up. So for example, here we have the albedo. You can see here we don't have the specular. However, we can very actually easily set some settings, like for example, we want this to be transparent, and we want this instead to be metallic, we want this to be specular. So we can do that very quickly, very easily. And you can see some other values like the alpha, for example, that we'll be using, as well as emission. So that's kind of eventually, once we do all these calculations, they need to go into those specific inputs, if you will, and that will render out the exact values that we want. And we'll be using that off of all of these inputs right here. So for starters, let's do this first line, and then as we kind of go through this, I can speed through things just so that this video isn't like 30 minutes long or something like that. So for starters, this is a very easy line. So we have this variable that we're defining called normal direction, and we have the safe normalize function. So this is just doing really just a standard normalize of a vector. And if you're not familiar, normalizing a vector basically means you're setting the magnitude of that vector to 1 while keeping the same direction. They do it in a slightly different way. Honestly, we're just going to be using normalize. And this is off of the normal of our model, so, or a specific vertex rather. So on any given model, you have a bunch of normal vectors that kind of point out how you are perpendicular to that surface, which makes it very easy to actually do a bunch of color and lighting calculations. So to do that, we first need to create a node. Everything you do is creating a node, and we need our normal. So luckily for us, we can get a normal vector here. Very simple, very straightforward. And we'll be doing this in world space. I don't want to go into heavy detail as to what spaces are. That's a whole separate video, and we'll probably do that later on in this series of videos. But keep in mind, we'll just be using world space for consistency's sake. We'll go ahead, drag that out, and you can put that into a normalized node. And that basically emulates that here. Perfect, very straightforward, very easy. Now, honestly, the next line here does exactly the same thing, except we're using that for view direction. If you don't know what anything is, I think the easiest way to find out is just to start typing into shader graph, and if it comes up, that's exactly probably what you're looking for. And again, here's our view direction. Another thing I should note actually is shader graph's documentation is actually really good. So if you have a question as to what a specific node is, for example, you can very easily find the description for it and see what exactly it's doing. So in this case, the view direction is from basically looking to the direction from the camera towards that specific vertex. So very convenient here. If we go back here, again, they run the normalize function. So let's do the exact same thing. Okay, so we have normalize for our normal vector and our view direction here. So that sets that up. The next thing here is they're creating a float variable, halves or basically floats with less precision basically. And they're running through a saturate dot view normal direct, of which we do that on the dot of the view direction and the normal direction. So I'm going to show this here. So we need to take the dot product of these, you just pipe in the data, and you can see kind of effects starting to come together. That's why I actually really like the preview for these specific instances, and it's kind of what makes shader graph really cool. And next, we run that into a saturate node. Not much of a difference, but that'll become all more apparent as we go through this. Make some space here. And next, we're calculating this rim variable. And so one thing to note about this is, so that's based off of this. So we always want to keep in mind that saturate is actually this view normal dot normal. If we actually go ahead and scroll through this a little bit, you get a little hint of what's actually being done. And this allows us to take a shortcut as opposed to creating nodes for everything. But realistically, the easiest way to go about this is just to, quite frankly, for all these functions, just create nodes for them. So like if you want per power, for 1 minus, you can run through all of these by creating nodes and creating a giant kind of graph. But we can actually take a shortcut. So if we go here, if you take a look at this Fresnel effect node, this is kind of a very common effect that's used, especially if you look at any of Bracky's tutorials. He uses this one a lot. And let's take a look at the code for this specifically. If I can zoom in. So this is taking the power of 1 minus the saturate dot normalize, and we actually literally just calculated that right here of the normal vector and direction. And in fact, lo and behold, this is the normal and the view direction, and it takes in a power value. What is happening exactly here? Exactly the same thing as this. So what that means is we can take a little shortcut. Let's go ahead and delete those, and let's create a Fresnel effect. We go ahead, put in our normal vector, we go ahead, put in our view direction vector, and we set a power. So the power specifically here is 0.5. Boom. And just like that, this whole line is encapsulated with this one node. And that's really awesome. We'll actually be using this a little bit later, as you can see here again, and that's just kind of the power of just once you play around a lot with shader graph and you learn kind of these nodes, you can start simplifying things in very easy and straightforward ways. So I just wanted to show this just to save a little bit of time. So keep that in mind. Other things here are, of course, we need to do the multiply and a plus on this rim factor. Now, let me show that really quick, and then once we've done that, we can actually start skimming through a lot of this. So for using properties, you quite literally just go ahead and drag them out and they become another node. So what we want to go ahead and do for calculating this rim variable is we go ahead, take this Fresnel effect that we just calculated and multiply that by 1 minus rim factor. There are a few ways you can do the 1 minus. My personal favorite, or I guess rather the easiest way in my opinion, is just to quite literally use a 1 minus node. And we need to drag this out into a multiply. I'm actually going to use B here for simplicity's sake. Okay, so there's a multiply of this 1 minus rim factor and the Fresnel effect. And then we also need to add in a rim factor. So let me go ahead, make some space here. And we drag this into an add. You can go ahead actually and connect this all the way here if you want. I personally find it convenient just to redrag the variable in so it looks a little nicer. And so yeah, that now creates our rim. And so we just need to keep in mind that the rim is the output that's coming from this specific node right here. And likewise, this, if we ever want to reuse it, is coming off of the Fresnel effect. So that's one thing that's not really as convenient as, let's say, for example, you're writing code. We don't really have names for these variables, but we get the visuals, which I think is kind of even more cooler in a sense. So the next part of calculating this rim is to saturate it. So let's go ahead and drag this out into a saturate. And keep that in mind right there. And now that we've calculated rim, we're actually going to be using that to calculate our emission. So emission is super valuable. You can see that's used here. I'm actually going to speed through all of these calculations real quick, just so that we can save a little bit of time. Okay, so those are the few nodes that we need real quick here. So we have created an emission variable, which is going to be the output from lerp, where we created a node for the color black. We have the primary here as a variable, and we throw that into a lerp, where we are lerping off of rim, and rim was the output of saturate. From there, we go ahead and add the rim times 0.5. So again, the output of rim here, and then we have a multiply by 0.5. And we go ahead and add that with the value from lerp. And last but not least, we go do a multiply here. Now you'll see that emission factor is not one of our properties. If we actually go look for it, we can just Control F. You'll see it's defined here as 0.95. So it's just a constant, so we can do it as a constant as well. If you ever want to, you can actually go ahead and it's right click and convert to property if you want to convert it to a property. I'm not going to do that for now, but if you want to, you can go ahead and rename that basically as a property for emission factor. And yeah, double check here to make sure that everything looks right. But again, that creates our emission value. And now the next thing we're going to have to do is this Fresnel. So just like above here, we have our power by Fresnel, so that is exactly this. So let's go ahead, scroll over here. We'll be using these variables into a Fresnel effect. So let's go ahead and do that. We have our Fresnel power, so let's go ahead, bump that in there. And so that again encompasses this. So just up to the power part. That's all we cared about. And next up, we need to saturate it. So let's go ahead and drag that into a saturate node. And that, just keep in mind here that this saturate is our Fresnel value. Now that we have the Fresnel value, we need to do another lerp, and then this is the lerp value. Now you can see, if you've ever played around with hand tracking before, this effect is starting to look pretty similar to what you might imagine it should look like. And that's because of this color value here. And now that we actually have color, and we know that emission is the output here, we can actually go ahead, drag this all the way over. So now we can do our actual first output. And so we know that for the emission, it's going to be color times emission. So let's go ahead, take this, and throw that into a multiply node. So this value here multiplied here. You can see that nice emission effect. Drag that onto your emission. And get the preview to update. Well, this'll change a little bit later, but now we kind of are starting to form the bases of what we actually want to have from Shader Graph, and you can kind of see the flow of things as it eventually comes into this final effect here, which is really cool to see. And so that's the color value here. Next thing is a completely separate step, no pun intended, and that's just to create the alpha value. And that goes into our alpha, which is perfect. So let's go ahead here, and we need to create a step. All right, so that sets the alpha value. We'll go ahead, drag that onto alpha here. And we can drag this over so that it looks not nearly as messy as I would have wanted, but that's good enough. And boom. All right, so that's all our calculations. Again, very straightforward, very simple. The last things here, we just need to make sure that our albedo is set to 0. So 0 is quite literally black, so do that. And we need to set our specular to 0. So specular here, again, set that down to black. We don't have gloss, so we can ignore that for now. And yeah, that's it. Very simple, very straightforward. Let's go ahead and save that, and here's the final effect. Now, we have this, we've gone ahead, let's go ahead, save this, and we have this default hand. So I'm gonna go ahead, Control D to duplicate that, and we can also go ahead and then just on this duplicate, I'm just gonna go ahead and change that to the alpha hand. Since we have all the same properties, everything should copy over pretty smoothly there. And let me just name this actually. All right, so this is our alpha hand mat. Let me just throw it in the top here so we have an easy reference to it. One thing to note here is we should set this to 3001. This is actually more because of that second pass, so you don't really need to do this, but just for consistency's sake, I'm gonna go ahead and set this to 3001. And let's go ahead, find our hands. So here's that where we need to set the material slot. Go ahead, set that. Boom, should update. And now, if you go ahead and try this with Oculus Link, or if you go ahead and try this in the headset, you should now see that our hands are working with the universal render pipeline. Of course, before it wouldn't work because it was a custom shader, and now we've gone ahead and ported that over. So hopefully that was very useful at minimum, just to see how you would go about porting it, or even better, now that you actually have hands that should work with the universal render pipeline. And we also got a little taste here of Shader Graph, which I think is really cool. So yeah, I think that mostly wraps it up for this video. We've basically gone ahead, shown how you can start with a completely working project and break it apart with the universal render pipeline assets here, but then put things all back together, which now you have the train scene. It works beautifully with the universal render pipeline, and now you can start playing around with stuff like Shader Graph and Visual Effect Graph, which we'll dive into in future videos. So hope you guys found this useful. If you did, make sure to leave a giant like on this video because it really does help out the channel a ton. And if you guys have any questions or things that you're excited about to now start playing around with the universal render pipeline, please let me know in the comments below. But that pretty much wraps it up. So thanks so much for watching, and I'll catch you guys in the next one. This has been FusedVR, and I'm signing